I'm more eager to introduce our next speaker. Please join me in welcoming Bista, a site reliability engineer currently at Versant. He's passionate about emerging tech and always pushing the boundaries of what's possible. Today, he will be sharing his expertise on automating static AI website deployment with Google Cloud Build and GitHub. He'll guide us through creating interactive web experience with Gemini AI and how you can seamlessly deploy your website with each code change. Let's welcome Prasidha.
Hello, everyone. Can everyone hear me okay? How was lunch break? Did you all enjoy the food? I really liked the wrap. The chicken wrap was really good. So much so that I had 2 of those. Don't tell Keshan, wherever he is. But now that's done, hopefully you're not sleepy. Hopefully you've got a bit of energy to listen to a few things about, Google Cloud and AI. I've specifically put in AI in the mix because I wanted to make it interesting. I wanted to get you all here because, I don't know, without the word AI, probably would have been hard to get so many people in the room. But yeah, all right, with that, let's begin. Thank you, everyone, for making time to come to this presentation on automating static AI website deployment using Google Cloud Build and GitHub. My name is Bista. Everyone calls me Pras for short. And I'm a senior SRE at Versant. I've also been recently lucky enough to participate in the Google Developer Experts program for Google Cloud. And very grateful for my mentors, Geshan, who always gives me a lot of opportunities and helps me out through these adventures. So I'm really grateful to my mentors and everyone who helped me in this journey. And hopefully that gives me a bit of credit to come and share this project in front of you all today. Please scan the QR code if you'd like to add me on LinkedIn, and also to get access to the code for this project, and also to the slides. You can also find that at the end as well, at the end of the slides. In terms of what we'll be learning today, there are a few things. We'll first learn what a static AI website is, what are some of the use cases and benefits for it, how is it different from a dynamic website. We'll look at the architecture diagram for this project that I built. We'll then dive into looking at how we can practically set this up in Google Cloud using Google Cloud Storage. It's actually really easy to deploy your static website in Google Cloud, and that's the point I want to make. I want you to take away, you can even count the number of steps that I'm going to show you in order to deploy your website to Google Cloud, right? So it's going to be that easy, and that's sort of the first part of it. So we'll deploy the website in Cloud Storage bucket. We'll point our domain name system to it. We'll configure DNS to point to that bucket. And that's pretty much all you need to get started with your website. And that's kind of what I want to share in the first part of the talk. The second part of the talk is then going to be, if you think about when you make a change to the website, how do you deploy the changes? Do you manually go ahead, after the code has been merged, changed, reviewed by your colleagues after it's been merged? Someone has to deploy it, right? And what I want to show you here is, in the second part, is how do you then automate any deployment to the website whenever you make any changes to it. So if you think about it, if you change, for example, the background color for the website, that change, we merge that change in. That change is then automatically published to Google Cloud using the CI/CD mechanism that I built using Google Cloud Build and GitHub, right? So we'll use a Cloud Build trigger. It's just a service, but that's sort of the concept that every time we merge our code, we need to be able to automatically deploy it. And once we look at that, we'll also look at this practically using a demo, because we'll all get excited, and without a demo, it just doesn't make the point. So I want to make the point by showing all, and hopefully the demo gods support me and the demo works, because sometimes you have technical difficulties as well. Pricing, as any other talk, I've been to a couple of talks since last year and this year, and every single time one of the questions from the audience is going to be, how much does it cost? So I've taken one step further, and I've included those in the slides for you all. So we'll talk about pricing at the end. So what is a static website? Do you always choose a dynamic one? Because dynamic website where you use tools like React and others give you more flexibility? Is it because it's fancier to use React or something like that to make cool websites? Have you thought about it when you start a project like this? So what is a static website, right? First of all, in order to make that difference, we need to know what the differences are. So static website is basically a collection of web pages, your typical HTML, CSS, and JavaScript files that are served directly from the server to any user without any sort of changes, right? So if you think about it from a perspective of a dynamic website, like Instagram or Facebook, whenever every one of us logs into these websites, the content that we see is different. So it's very heavily personalized. The content that we see in these dynamic websites are the type of content that we like and the type of content that we want to see, right? So it's personalized according to the user. But in terms of a static website, every single user that logs into the website sees the same content. The content is exactly the same, right? So that's kind of one of the main differences between a static and a dynamic website. So what are some of the use cases then for it? So if you have a blog, if you have a resume, if you're trying to look for a job, that's probably a little thing that you can do, a little side project where you create your resume and host it in a bucket or something and make it a static website. That you can then learn how you can build a static website. You can showcase your work in a more practical way as well, right? So these are some of the use cases. And one of the other examples here is a static front end with a dynamic backend using APIs, which is one of the use cases for this project today, right? Because we've got a front end, HTML, CSS, basic HTML file, but it interacts with an API, so it gives it a bit of a dynamic functionality. Now, when you think about benefits of a static website, think about performance, right? Because, like I said before, every single user that logs into the website gets the same content. So if you think about it, if you use features like a content delivery network, CDN, where your website is hosted closest to the users, the servers that are hosting these websites, they're all over the world. And so if a user logs in from Australia, they then get directed to the server that's closest to them in Australia, right? So if you use features like CDN on top of a static website, that really, really increases your performance because you don't have to do any processing, right? You don't have to change the content that you show to your users based on who the user is. You basically have the same file stored in servers all across the world, and you present that to the users. Security, so similar concept before, because a static website doesn't have functionality, like it doesn't talk to a database most of the times, it doesn't run scripts because we're not running any scripts, we're serving the files as is. There's a less chance of security attacks. So the attack surface is really low, right? So that's the other benefit. Cost effective, because creating a static website and hosting a static website, it doesn't take a lot of server resources. Many services like Netlify, even Google Cloud Storage, AWS, using those free tiers, you can probably host a website for free. So it's cost effective if you compare it to a dynamic website, which consumes a lot of server resources. It takes a lot of memory, CPU to process, to think about what the user wants, and then presenting that to the user, right? So that's kind of the main difference. And then simplicity, basically effectively because of those reasons, because scaling, all of this can be argued, right? So depending on how big the static website is, it can be really simple to host and scale. But if you think about, if you have like 1 million blogs in a static website, you might still encounter, challenges in terms of performance, and other metrics. So simplicity is, arguable. But it's simple for a certain number of, certain amount of, I guess, users or content that a static website has. So now that we know what the main sort of difference is between a static and a dynamic website, it's important to know that before we start any project that we think about these things, because you don't want to be in a situation like this where you kick off by saying, hey, we're going to be okay with a static website. You start building it, and all the way halfway down the line, you're like, oh, it's not going to, this doesn't cater for all our requirements, so you have to rebuild it, and you have to change a lot of things to make it dynamic, right? So it's really important for us to think about it upfront. And that's the point I kind of wanted to make. And for little projects, for simple things that you want to build, it's a really great way to start because you save time, you save money, you save a lot of it saves you from a lot of challenges that you have to go through if you're trying to build a dynamic website. For example, think about a front-end website that uses React. You have to learn React. You have to figure out specifically how React works. And where you're going to host it. All of those things. It becomes a bit more complex, right? So that's why I would think and recommend, for little things, side projects, things like that, static website can be a perfect fit for you. All right, so now that we know what a static AI website is not an AI website, right? I want to show you the architecture for today's project. So in the middle, we have that's the layout of the website. It's hosted in cloud storage. That's the icon up there. So that's the website. A user visits the website. they want to basically, the only functionality it has, it interacts with Gemini AI. So whatever the user types in, it gets a response from AI, right? So user comes into the website, they type in a query. That query gets passed into Cloud Functions. And I'll talk about that in a second. And Cloud Functions in Google Cloud is basically a service where it's a serverless service from Google Cloud, where in your favorite programming language of choice, like Python, Node, whatever, you upload your code, and it just runs it for you. So it's a serverless. You basically pay for only what you use it for. It fits my model, right? So I only want to invoke it when a user goes into the website and invokes it using a query, right? So for that, I found it a really good use case. So it invokes Cloud Functions, and Cloud Functions is then, the service is then responsible for sending that request to Gemini AI and getting that response back, and then sending that response back to the user. Now you might ask, why do I have the Cloud Function service in between? Why did I not directly invoke Gemini via the website, which is basically a HTML page, which I'll show you in a second? That could be done. That can totally be done. The reason I didn't do it is because if you think about it, the static files that the user sees when they log into the website, everyone gets the same thing. If I had to invoke Gemini directly from the website, I would have to put the AI, the key for the Gemini service into the HTML page, which I initially did, and I was like, oh, this is a security risk. I don't want that key to be shown to every other user that visits the website, because you can see clearly, turn on developer tools, you can see that the key is being passed in, right? So that's the sole reason I wanted to avoid, and that's why I've got this kind of like a middleware service in between, and that handles the interaction between the AI service and the user. And I'm pretty sure, like some of us are probably, you probably know a better way of doing this. Please let me know. I'm always interested in learning, and that's just one way of doing this, right? And one of the easiest way I found, and I just, plugged it in there. So, oops, sorry about that. Now, in terms of the second part of this, where you have the deployment workflow, the picture that we just saw was for the website and how the user interacts with it. Now, this is the second bit for it, right? So let's say I want to make a change to the website. Let's say I want to change the background color, right? When I make that change, I put that code up for review. My colleagues review it in a context where you're working. That's what happens. Once that code has been reviewed and I merge it in, the workflow kicks in. At the top, we merge that code to our mainline branch. Once that happens, our Google Cloud Build service gets triggered, which we'll see how we can configure in a bit. Cloud Build then runs Terraform. You can basically run anything inside this environment. It's basically an environment where you can run commands. You can run bash commands if you want. You don't have to use Terraform is my point, right? You can run basically anything in there to do the thing that you want to do. In this case, I want to basically be able to, whenever I make a change, deploy that change to Google Cloud. So that's what it does. So every time we make a change, merge it in, Google Cloud Build gets triggered. That initializes Terraform in that environment, and Terraform then is responsible for updating the Google Cloud infrastructure. And in this case, we just have two services. It's Google Cloud Storage for hosting our website, and the Cloud Functions, which uses that code to interact with Gemini. And that's it. So it'll make more sense in a bit when we look at the example here, and when I show you the demo as well. So now let's see how we can set this up, right? So a few things that we need, obviously a Google account. You can sign up for a free tier where you get like $300 for like 90 days to play around with. And that's a really good way to start with. And you need a GitHub account, because you don't need a specifically GitHub account. You can use GitLab, you can use Bitbucket, because obviously they all support CI/CD, and obviously in a different way, but they do support them. And a custom domain, because I want to host the website with a certain domain, I need to use a domain. So in this example, I'm just using my custom domain, learn with Pras, and that is kind of all you need. And I want everyone here to think about the number of steps here and how easy it is, right? So if you wanted to build your own website today, how many times do I have to click on the console, and like how many steps do I need to? There's not a lot, right? So I want all of us to think about it. So let's start it off. First thing we need is a bucket, right? So the only important thing here when you go to Google Cloud Console and create a bucket is the name of the bucket. So the name of the bucket should match the website's domain that you want to host it on. So in this example, my domain is learnwithpras.xyz, and I just chose the subdomain Explorers to be able to host this website on, right? So I choose that. You can choose other properties like region, where you want to host where you want the bucket to be, things like that, like ACLs, all of that. But generally here, the most important thing is the name. That needs to match the domain that you want to host the website on. You create the bucket. After that, you edit the bucket's configuration. you tell the bucket that you want to make it a website bucket, and you tell the bucket what are the main files that is used to host the static website. In this case, I just have two files, index.html, that has the main logic for calling AI and making it a bit visually appealing. And the second page is for error paging. So if a user visits a page that doesn't exist, they get the 404. And that is all you need. So two files, created a bucket, created two files, we'll upload it in a second. But the one thing that we need to do before that is we need to obviously verify a domain. So how does Google know that the domain that I'm trying to use for the bucket is owned by me? So that's where Google then redirects you as soon as you try to edit that website configuration. In this case, you could be using anything like Google Cloud DNS. I'm using Cloudflare. So what it did was it redirected me to Cloudflare, and it automatically added a text record for me. So if you see that record, the content of that record wasn't generated. It was generated by Google, and it redirected me to Cloudflare, and it automatically added that record for me. But basically what happens is, once that record's there, Google can then do a query on this domain, and then it will receive that response, that content, right, the text record. And that's how Google can verify that we own the domain, if that makes sense. Once you verify the domain and the bucket's set up, the other thing that we need to do is make the bucket public. So when you look at this is the what do you call it, access. So the buckets policy, basically we're updating the policy to allow, if you look at the principles, it's all users. So basically not just anyone from the internet, that's what it means. But if you look at the role, it's a bit restricted. Generally, most of the times you wouldn't do this. You don't want to make your bucket public. You don't want your data to be accessed by anyone else outside. But in this case, because it's a static website, it has to be public because you want everyone else in the world to interact with the website, right? So it's okay to make it public in this case. So we're saying all users, but we're still restricting the role. So we're saying we're not giving them admin permissions. We're only saying whoever has access to this, all users, can only be able to view the objects. They won't be able to, let's say, delete the index.html file, for example. They can't update it. They can just view it, right? So we're still restricting it, but it's open to public. So that's important to know. Once that's done, the final thing, obviously, is to upload those files that we said to Google that, hey, these are the files that you want to use for your website, and those are the files that I've uploaded. As soon as that's done, that is pretty much it. So we're good. So I want to ask everyone, so how many steps did we take? We created a bucket. We changed a few configuration for the bucket. We pointed our DNS to it. There you go. It wasn't hard at all. I really don't think it's hard. And when I show you the HTML file that I've got, it's literally I asked ChatGPT to create that HTML file for me. I'm not a front-end engineer, right? So when you look at this, it looks nice. For a back-end engineer, that looks really nice for me, right? And I use ChatGPT, so I'm not a front-end engineer at all. And I was able to create something like this, right? So that is what I have. In a few steps, I was able to create my website, and it's up and running. If a user visits a page that doesn't exist, I've got that 404 page. They get redirected to that. So little things, even though it's like a simple website. So now, with that, I want to say that that's the first part of the talk, and I wanted to make that point that it's very easy. You can get started today. So build a simple HTML file that probably doesn't do anything. Click a few things, configure your bucket, you point your DNS, and you're done. It's that easy to get started. So now let's move to the second part of the talk, where I want to show you now that we have our website running, users are visiting it, they're interacting with the website, they're interacting with the AI service from the website. How do I then make it easy for all developers working on this project such that we can focus on building? We can focus on building, we can focus on developing new features for the website, and then the deployment side of things is all handled by the automation system that we've built, right? So that's the kind of takeaway I want you all to have from this. And for this, we're using the Cloud Build Trigger service in Google Cloud. It's basically saying, trigger, basically every time we merge, GitHub sends that event to Google Cloud, and then Google Cloud needs to do that magic of deploying and updating your Google Cloud infrastructure, right? In order to do this, we create a trigger. The most important thing here is probably the event. So we're saying every time we push to a branch, we want to trigger this workflow. To create a trigger, we need to do a few things. So now if you think about how does Google Cloud know which repo or where to go and fetch that code? So that's the kind of linking that we're doing here. We need to create a repository. Basically, we need to link a GitHub repository. In order to do that, I chose this configure connection option. An important part here is, if you look at the bottom section here, as you're configuring this connection, Google Cloud auto-generates a token from GitHub that it then uses to interact with GitHub every time we trigger this workflow. So as we're authenticating, as we're creating this connection, a token is then generated by GitHub, which is then stored in Secrets Manager in Google Cloud. And that's how the authentication works between GitHub and Google Cloud. So every time we trigger the workflow, Google Cloud Build then grabs that secret from Secrets Manager, uses that token to then interact with GitHub, if that makes sense. Because it needs to be authenticated to grab the code base. Although it's public, I actually need to investigate this because I had this question myself. Because this repository that I'm using is public, I don't know why we need this token to interact, and fetch that code, right? Because anyone could probably. So that's a question for later. Even I have that question, right? But basically, that's what's happening here. If it was a private repository, for example, that's probably more beneficial if it's a private, right? Because public can't access it. We use that token to then grab the code and deploy. But in this case, I'm not too sure because anyone can effectively download it. Why do we need a token? That's a question for myself. So yeah, that's basically what's happening. It's configuring the authentication between GitHub and Cloud Build. Because otherwise, anyone could grab it, right? Anyone could authenticate with your service and fetch your code. So that's done. Once that's done, the final thing is obviously install Cloud Build application. This is on the GitHub side. So you're basically installing the application. And even then, we're restricting it to some repositories. So you're not giving this service access to all the repositories. You can restrict it to only the ones that you care about. And in this case, it's just for the AI website. So this Cloud Build service cannot interact with any other repository in my organization, if that makes sense. And that's it, right? So once we've done that, as you can see, we're finally able to create that trigger. So that's the connection, that's the repository over there, and that's all done. It's enabled. Now, how do we test this? So we've configured all of that. Now, you can find all the code for this to deploy this in Terraform. If you visit that GitHub repository that I've got, you can find that at the end as well. So yeah, you don't need to know exactly how many steps that I've done. It's all been captured in code. And then yeah, so that's kind of the trigger. So how do we trigger the build? So once we've deployed the trigger, once we've configured that authentication, basically what I've done is, I've created a file, a Cloud Build YAML file. I basically committed directly the change to the mainline branch, and that triggered a workflow in Cloud Build. As you can see, this is the Cloud Build environment, and what you see on the right is the output of Terraform, and Terraform's basically gone in, it's assessed the current environment, and it's made the changes that it needed to make. For instance, down here, it's added 5 resources, changed 1, and destroyed 3. So it's updated the website with the newest code change. And we'll look at that in demo now. All right, so before we move to the demo, so this is obviously live, as you can see. We can try interacting with it. For example, just making sure that it works before I make an update. Maybe I want to learn Python today. It's sending that through. As you can see, I'm not a front-end engineer, but I've been able to, create a spinner. That's pretty cool, right? And that's all due to ChatGPT, but got a bit of help. But yeah, as you can see, it's working. Want to learn Python. Got a bit of formatting done. A very simple website, and I'll show you the code for it. It's a very simple HTML file, and I can interact with AI. The response here is being generated by the Gemini AI service. So it's all working. Now let's go look at the code. So what I've got here is the repository on the right. Because in Visual Studio Code, you can do things like preview your HTML file on the right. That's what I've got up here. What I'm going to do is I'm going to quickly explain. As you can see on the left, this is the HTML file. I've got everything crunched up here. You can obviously create separate CSS files, things like that. But as you can see, I've got all my CSS up here. All the way down here, if we go, the real logic that calls the Google Cloud function is down here. If you see call AI, yeah, this guy. So it uses fetch, JavaScript. It's running the script directly in the user's client's browser. So nothing's happening on the server, right? The website gets served directly to all the users the same way. The user comes in, puts in a query, JavaScript runs, it invokes the function. Function then is responsible to fetch that response back from AI, right? And if you look at the function code for it, TypeScript, it's a very simple function. As you can see, all I'm doing is using fetch again to call AI, but this is the important part. I'm using an environment variable to pass in the key, right? Because I want that to be safe. I want that to be not to be revealed to anyone, right? So that's the code. If you look at the left, there's a bit of Terraform code here, which we're not really interested in, but it's all there. It's all there. Everything's deployed using infrastructure as code, so I can reproduce it. I can delete the whole infrastructure in under a minute I can recreate it in under a minute, right? So that's sort of the power of Terraform, automating all your infrastructure. It's all in code. And yeah, so that's sort of like an overview. What I want to do now is I want to make a change to the website, and then I want to quickly create a pull request, merge that in, and see if that gets deployed, to the cloud storage bucket. Everything gets updated, and we'll verify that the change works as well. So if I go here, let's say I want to change this background color to blue. Okay, as you can see, whatever, I just changed it to blue. It was pink, right? So what I'll do now is, this is just to show you. So Terraform uses a template over here. So what I'll do is I'll now create a branch. Test color change. I've already tried it. Change the color. I've created a feature branch, like you would in a development workflow. I made my change. I've pushed the change. I'll go look at the change quickly. It's just a literal color change. As you can see, in a typical world, you'd get your colleagues to review and approve before you merge it. But in this case, it's just me. I'll review my code myself and approve it myself. That is amazing. Obama, giving medal to Obama, if you've seen that one, right? Yeah. So, yep, one more time. All good. I'm happy with the change. What I'm going to do is I'm basically going to merge it. Delete the branch. That's merged now. Because I've configured the workflow, I can go directly here. I can see that it's building. It redirects me to Google Cloud. This is the Google Cloud environment where Terraform is being initialized, and it's picking up the changes. As you can see, it's installing. So currently, it's installing a few things. Yep, initializing Terraform. It's compiling the node files now, the TypeScript files. And then you'll see that now it's starting to run Terraform commands. Currently, it's running Terraform plan. And then right after, it's going to run Terraform apply. You can see it's changing because Terraform shows you what it's going to change. It's telling us that it's going to add 5 resources, change 1, and destroy 3, basically replacing the index.html file from the bucket, such that the new color change gets picked up. Okay. Meanwhile, so this is the other thing that I wanted to show you. What happened here is we've got a downtime. Why is that happening? Now that's happening because you can see that in order to replace update the file, what Terraform's doing is it's actually deleting the file first, wherever that is. I think over here, and then it recreates the file, which is not great. This is something I should probably handle for, and there's probably a way to handle it. And that's probably that was one of the questions that people had last time, so I'm covering for myself here. Basically, that's something we need to be handling, in a real sort of world scenario where you have a website where thousands of users are visiting a website. You don't want downtime, right? So it's probably up by now, not up yet, okay? But yeah, that's what's happening. So it's destroyed the file, it's recreated the file up here. It's nearly done. As soon as this is done, we'll see that the website's back up again. While that's happening, because it's going to take a minute, I don't want to keep us waiting. What I'll do is I'll go into the pricing slide, and we'll come back to the website once it's deployed, which shouldn't take that long. So if I go back to the slideshow mode, so pricing. So I included this slide here because pricing is not straightforward. Any cloud you choose, especially with subscription-based services these days, you might find that pricing is a little bit trickier to come across and present. For example, if you wanted to know how much a solution costs, it's quite tricky because now let's look at the first 2 services. Obviously, there's a lot of data here. Let's focus on the first 2 services. If you look at cloud storage, is it as simple as saying, hey, I pay, for example, $5 a month, and that's probably it. It doesn't work like that because there are different factors that come into play when you think about pricing, right? Look at the first one. So number of API operations. So how many times has the cloud storage bucket been accessed? How many times have we visited the website? Because every time we visit the website, the index.html file is being fetched from the bucket, right? So how many of those operations have happened in a month? The second criteria is data transfer. So for example, if someone from the other side of the world is visiting this website, the data is traveling all the way down to the other side of the world. That's data transfer. That's the other criteria that you need to think about. Inbound data transfer is free for cloud storage. This is very controversial because you might think, oh, wow, cloud storage is free. You might start, putting terabytes and terabytes of data into Google Cloud. But think about when you need to take that data out, because you're still going to have to pay for the data transfer, right? So inbound is free, which can be helpful in certain scenarios, but that doesn't mean you dump everything into Google Cloud or any other cloud, because although even inbound data transfer is free, you still have to pay for outbound data transfer. All that 10 terabytes of data, if you ingest it, think about the cost that you're going to spend if you want to take that data out, right? So that's the other thing. And this pricing is then based on a region. US Central 1. Every region has different pricing, right? So if you take all that into consideration, and if you think about this other service called Cloud Run, which we're using for that that function, it depends on the amount of CPU that's used, the amount of memory that's used, and the amount of time you make a request to the service. So there's different criteria again, and that's also based on region, right? So I wanted to make a point here that it's not straightforward. Whenever we're thinking about pricing, we need to be mindful of a lot of things. And a tool like Google Calculator, which I've linked down here, you can use a tool like Google Calculator. There are many open source tools as well that can help you with pricing. So that's why I've got this here. Is you need to think about this as well. And taking this example of this static AI website, I put up a sample use case, and I put up higher numbers like 100,000 API operations. I just wanted to show you like a reference use case of how much it could cost if you had a static AI website like this, and if you had a lot of people visiting it, like 100,000 operations in a month, right? So if you had 100,000 operations in a month, 10 GB, 10 gig of data, let's say you had a blog site, you had lots and lots of blogs, about 10 gig of storage, 10 gig of data transfer because people are visiting your website, and maybe 2 gig of storage of the actual files that are stored in the bucket. You would pay about $1.75 for the month. Similarly, for Cloud Functions, if you had like 1 million requests to the service, and each time it took about 200 milliseconds to process that request, and if you provided the service 128 megabytes of memory, you would spend about $5, $5.50 per month. And if you keep going, so for a service like this, I'm thinking about heavy usage, 100,000 operations, whatever, you might end up paying $11, $12 a month for a solution like this. So yeah, hopefully that gives you like a bit of overview on what to expect and how to think about pricing. And it's not just straightforward. There's a lot of criteria into it. All right, so let's go back to the build. Yeah, all right, so as you can see, the build has succeeded. We can go look down here. It's updated, it's added 5, changed 1, and destroyed 3 resources. Basically updated the HTML files, all of that. It's all done with that. We had a bit of downtime. Let's see if the website's up. And there you go, the website's up, right? So basically, it's gone in, it's populated the new website file in all the cloud storage servers all across the world. It's still, fanned out. Not across the world, it's only in the US too, sorry. So it's in that region. It's still across multiple data centers. So it's obviously, creating that file across those data centers in those servers. And now that's finally done, and we're able to access the website. Let's see if I can still interact with AI. Maybe I want to learn Kubernetes now. If I can spell it, but hopefully, yeah, I can figure it out. There you go. So still working. Nothing's broken. Demagods have supported me today. That's nice. Yeah, so I think that's pretty much it. So, hopefully, in terms of takeaway, right? So before I go to the questions, there are a few more things that we can do to make this website even more, performant and a bit more secure. And to do those things, if you think about CDN, Content Delivery Network, Google provides its own CDN. We can put that CDN in front of this bucket such that, what then Google Cloud will do is you use that CDN service to host our website all across the world. It puts them in all the servers, in all the edge servers all around the world, such that when a user, at the other end of the world, if they visit the website, their request goes to the closest server. So that's the whole point of CDN, right? So making sure that users face less latency. They don't have to travel all across the world to US, where the bucket is, which increases latency, right? So if you think about it, it has to go all the way US, come back. There's a bit of latency. The round trip time takes a bit of time. Right, so, and that's all, that can be reduced, and your website can be made performant if you use something like a CDN. And if you think about security, we can use a service like Cloud Armor, I think Google Cloud has. All the clouds have their own version of it. So basically, a web application firewall. So basically, deploying a WAF in front of the CDN, what that does is then it protects you from layer 7 attacks, DDoS attacks, SQL injection, like cross-site scripting, all of those things by default. So plug that service into the solution. That you can also then add security per shot, and you can find more visibility into your service. And those are the things that I could do to enhance this project. With that, I think that is all. If you have any questions, please let me know. Hopefully, you got to learn a few things. Thank you.
Thank you, Pras. I really love this step-by-step approach of deployment and also the demo you had. Is there any question? Seems like your presentation was really fantastic since we have no question.
Well, no one understood anything. Too complex.
All right.
Well, thank you all. Thank you so much for your time. I really appreciate it.